Hey everyone and welcome back. So today we are going to solve a problem which is similar to our previous problem, which is find an element in a rotated sorted array. But this time we have to find minimum in a rotated sorted array. Okay, so let's see the problem. So we have array like this and we have to find what is the minimum value in this array. So for this it is a 1, right? If we take another example 4, 5, the minimum value is 0, right? Similarly for this example our minimum value is 11. So the question is we have to find minimum in the rotated sorted array. If it is a rotated sorted array, that means we can use binary search, right? Okay, so before that we already know brute force, so you just have to run a loop and finds the minimum in this array. So it will take a big of n. So brute force is big of n, but we need a solution in log n and we have a rotated sorted, that means we can use binary search, right? So in previous problems we were kind of dividing our array into two portions, right? Something like this, right? So in this problem we are going to use similar concept. So let's look at the first example. Let's say I have low here, high here, and my mid will be here, right? Now here you can see we have two portions from low to mid and mid to high. Now we have to find minimum. So first we have to distinguish in which portion of my array we can get our minimum. So if you look at this portion low to mid, we can say our minimum is not in this portion, right? And it is sorted. If it is sorted, that means this portion is our second half of the array. Means if you write your array 1 2 3 4 5, if it is sorted, that means it is second half of the array. So we can say our minimum will be lying in another portion, right? So if you look at this 5 1 2, it is unsorted and our minimum is in this portion. So if you look at it, that our minimum lies in this unsorted array, not in this sorted. So we can easily check which array is my sorted or not, right? We can write a condition if my array of low is less than equals to array of mid. So we can say we are in the sorted portion, right? 3 is less than 5. Similarly, if we look at this case, we have low here, we have high here, and our mid will be at this 7, right? So we have this portion and we have this portion. So if you compare, this portion is sorted and this portion is unsorted. So our minimum lies in this unsorted portion, right? Similarly, for this low, high, then our mid will be here, right? Now in this case our whole array is already sorted. Till now we were saying we have this partition and this partition, right? So this one is sorted, this one also sorted. So how we can say that my minimum lies in unsorted array? But for this example we don't have any unsorted partition, right? But my minimum lies in this first sorted. So what we will do, even if we are in the sorted portion, we will calculate our minimum, right? Because it might happen that this first element of this sorted array might be my minimum. So we can calculate our minimum with the array of low value, and after picking up this value, means we considered the minimum value from this partition, so we can eliminate this partition and we can move our low to this value, right? So we can move our low to this value. So this is our condition to find the minimum in the sorted array. Now our low is here and our mid is here. So now again we will find our mid. So it will be 3 plus 4 by 2, it will be 3, right? So our mid will be here. Now again we can say we have this portion and this portion, right? Low to mid and mid to high, both of them are sorted. So both of them are sorted, we can find the minimum with this low, right? So our answer will be updated with this 1 value instead of 3, right? Initially we have answer 3, then after updating it becomes 1. So currently my answer is 1. Now again I can move my low. So this will continue. So basically we are shrinking our array, and every time we are shrinking, we are picking up the first value of that range, right? Because it is a sorted, so first value is the minimum for that range, right? So our answer will be here 1. Now what is the else condition, right? For this example, our whole problem solved in this if condition only, right? So now all these 3 examples will be solved in this if condition only. Now when this else condition will be executed, so for this let's take another example. Let's say we have 3 1 2, we have low here, we have high here, and our mid will come here, right? So we have this portion and this portion. So now if we compare our value at the low, which is 3, is less than equals to 1, no, right? So in this case our if condition will fail. If our if condition is fail, that means we are at this else condition, and in this else condition we are going to check for this portion, right? In if condition we are checking for this portion, and for the else condition we are checking for this portion. So this time our minimum will be 1, right? Because we are checking for this portion, and for this portion our minimum will be this one. So we will again write a statement to find our minimum, right? Because we have to find minimum in both of the portions. So if we were able to find our minimum in this portion, that means we can move our high to the left. So our high will be moved to the left, so our high will be shifted at this. Then again we can solve, but we got our answer, right? So this is the whole code for this problem. So basically we have 2 portions, one is sorted, one is unsorted. So this condition will pick the value from the left portion, this condition will pick the value from the right portion, right? So it is a binary search, so our time complexity will be log n. So let's write a code. So this is our problem. We have array which is rotated, and you have to find the minimum value in this rotated array, and we have to solve this problem in a log n time. Okay, so let's first declare our size of array. After that let's declare our low and high. Also let's declare our answer, right? So initially I'm keeping my answer 1e9. Basically 1e9 is 10 to the power 9, right? So in this problem we are finding the minimum. So our minimum is 0. So if I do a 0 here, so every time we find a minimum, 0 will always be the minimum, right? So to avoid this condition, we will keep our answer at the max. So here you can also write int max. Okay, so whenever you are finding minimum, always keep your answer or any other variable at the int max, or when you are trying to find the max value, in that case you can keep int min. Now let's write our loop, then we will calculate our mid, then we will write a condition to check are we in the sorted portion or not. So this will check that if my low value is smaller than the mid value, that means we are at the sorted portion, right? So we will calculate our minimum and move to the right side, else again we will calculate our answer and move to the left side. Okay, so for the first portion we will get the minimum at low index, but for the second portion we will get minimum at the mid, right? Because we are at the mid means low to mid, mid to high. If we are in the portion of mid to high, then mid is at the minimum position. So here we will pick the minimum from the mid index, then here we will return our answer. So let's run it. Okay, it should be nums, so I will change here it as a ARR. Similarly here, so our initial test case got passed, so our code got submitted. So this is our whole code for this problem, and time complexity is log n and space complexity is wig of 1. So that's it for today. Until then, thank you everyone, have a nice day.